Another day, another story. As new research casts doubt on a leading theory about how the Moon came into being, explore various lunar formation models. The origin of the Moon is a topic that has fascinated scientists for many years, and several theories have been proposed to explain its formation. Welcome to Tabo Eminent Channel. The most widely accepted theory today is the giant impact hypothesis, which suggests that the Moon was formed as a result of a catastrophic collision between a Mars-sized object, sometimes referred to as Theia, and the early Earth about 4.5 billion years ago. Here's a more detailed explanation of this theory. Giant impact. According to the giant impact hypothesis, early in the history of the Solar System, a Mars-sized object, Theia, collided with a young Earth. This collision was a high-velocity impact, and it was so powerful that it led to the ejection of a large amount of material from both Theia and Earth into space. Debris disk. The material that was ejected from both bodies formed a swirling cloud of debris around Earth. Over time, this debris cloud began to coalesce due to gravity, forming a disk-like structure known as the accretion disk. Moon formation. Within the accretion disk, small particles began to collide and stick together, gradually forming larger and larger objects. Eventually, one of these objects grew large enough to become the Moon. This process is known as accretion. Moon's evolution. The Moon continued to evolve over billions of years, undergoing processes such as volcanic activity, impacts from meteoroids, and geological changes. These processes shaped the Moon's surface and created the features we see today. The giant impact hypothesis is supported by various lines of evidence, including computer simulations, isotopic analysis of lunar rocks, and the Moon's composition, which is similar in many ways to Earth's mantle but lacks some elements commonly found on Earth's surface. Additionally, the Moon's small iron core suggests that it did not form independently but rather from material that originated from both Earth and Theia. While the giant impact hypothesis is currently the leading theory for the Moon's formation, it's important to note that scientific understanding evolves, and ongoing research may refine or expand upon this explanation in the future. Earth smashed into planet Theia. Known as the giant impact hypothesis, the reigning lunar origin theory holds that the Moon formed when Earth collided with a planet half its size, roughly as big as Mars, some 4.5 billion years ago. Scientists call this imagined planet Theia after the deity who gave birth to the moon goddess in ancient Greek mythology. The crash caused debris from both celestial bodies to orbit Earth, then a ball of partly molten rock rather than the solid orb we know today, and eventually coalesce to create the Moon. Dating back to the mid-1970s, this model implies that the Moon is an amalgam of materials from both Earth and Theia. A study published March 25 in the journal Nature Geoscience called the giant impact hypothesis into question by showing that the Moon's composition is nearly identical to Earth's, suggesting that another planet had little or no contribution after all. The term, Earth smashed into planet Theia, is a simplified way to describe the giant impact hypothesis, which is a scientific theory that suggests the Moon was formed as a result of a massive collision between a young Earth and a hypothetical planet-sized object known as Theia, about 4.5 billion years ago. Here's a more detailed explanation of this event. Early Solar System. Around 4.5 billion years ago, the Solar System was a chaotic place with numerous small and large bodies orbiting the young Sun. The early Earth was also forming during this time. Formation of Theia. Theia is believed to have been a planetesimal, a relatively large object in the early Solar System, possibly similar in size to Mars. It orbited the Sun in a different region of the Solar System. Collision. According to the giant impact hypothesis, Theia's orbit eventually brought it into close proximity to Earth. The two bodies collided in a high-velocity, head-on collision. Catastrophic impact. The impact between Earth and Theia was incredibly powerful, releasing an immense amount of energy. This energy caused both Theia and parts of the early Earth's outer layers to be vaporized and ejected into space. Debris cloud. The ejected material formed a massive cloud of debris around Earth. This cloud of debris contained a mixture of Earth's and Theia's materials. Accretion disk. Over time, the debris in the surrounding space began to coalesce due to gravity, forming a disk-like structure called an accretion disk. Moon formation. Within the accretion disk, particles started to collide and merge together. Eventually, they formed larger and larger objects. One of these objects, made predominantly from the debris of the impact in Earth's mantle, grew to become the Moon. This process is known as accretion. Lunar evolution. After its formation, the Moon continued to evolve over billions of years. It cooled and solidified, developed its own surface features through volcanic activity and meteoroid impacts, and settled into its current state as Earth's natural satellite. The giant impact hypothesis is supported by a variety of evidence, including the similarities in the isotopic composition of lunar rocks to Earth's mantle, computer simulations of the impact event, and the Moon's relatively small iron core, which suggests that it formed from materials that originated from both Earth and Theia. This hypothesis provides a plausible explanation for the origin of the Moon and is the most widely accepted theory in the scientific community. It helps us understand how our Moon came to be and how it has played a role in shaping the Earth-Moon system. The Moon once filled the Pacific Ocean's basin. Charles Darwin's son George, an astronomer and physicist, first proposed the fission theory of moon formation in the late 1800s. According to this hypothesis, a chunk of matter spun off from a whirling Earth early in the history of the solar system and became our planet's satellite. Geologist Osmond Fisher took the concept a step further, proposing that the Pacific Ocean occupies the space once filled by the Moon. It wasn't until well into the 20th century that fission fell out of favor, partly because scientists determined that a force capable of dislodging a moon-sized piece of Earth would have destroyed the planet. Lunar rocks collected during the Apollo missions indicated that the Moon was once hotter than Earth, offering more evidence against fission. Earth ensnared a drifting Moon. According to the capture theory, the Moon formed elsewhere in the solar system and happened to hurtle past Earth at just the right moment. As a result, Earth's gravitational field captured the Moon and brought it into orbit. Scientists now believe an object as large as the Moon would have broken apart or bounced off after encountering the forces surrounding Earth. They also consider it unlikely that conditions would have allowed such an auspicious meeting. Earth and the Moon were twins. The condensation or co-accretion hypothesis states that the Moon and Earth were born at the same time, sprouting from a single cloud of material within the original nebula that created the entire solar system. This event would have taken place shortly after the Big Bang some 13 billion years ago. If co-accretion formed Earth and the Moon, however, gravitational forces would have fused both celestial bodies, or they would share more basic characteristics, experts now think. The idea that Earth and the Moon were once considered twins, in the context of planetary formation, is a concept rooted in planetary science and the study of celestial bodies. While Earth and the Moon are not identical twins in the way that biological siblings might be, there are some similarities and connections between them that led to this characterization. Composition. Earth and the Moon share some similarities in terms of their chemical composition. Lunar rocks brought back from the Moon during the Apollo missions and subsequent lunar missions have shown that the Moon's surface is composed of materials similar to those found in Earth's crust, such as silicate rocks. This suggests a common origin for both bodies. Size and distance. The Moon is relatively large compared to Earth when compared to the sizes of other moons in the solar system. In fact, Earth's moon is the fifth largest moon in the solar system. Additionally, the Moon is relatively close to Earth compared to the distances between many other planets and their moons. Orbital relationship. The Moon orbits Earth in a way that is somewhat unique in our solar system. Earth's moon is relatively large compared to the planet it orbits, and it's located at a significant distance from Earth. This configuration is not as common in the solar system, where most large moons are relatively small compared to their host planets. The prevailing scientific explanation for the formation of the Moon, as mentioned earlier, is the giant impact hypothesis, which suggests that the Moon formed from the debris of a massive collision between the early Earth and a Mars-sized object named Theia. This theory explains the similarities in composition between Earth and the Moon and their gravitational connection. So, while Earth and the Moon are not identical twins, in the way that siblings might be, they are certainly closely related celestial bodies with a shared history. The study of the Moon's formation and its connection to Earth provides valuable insights into the early history and processes of our solar system. 2 moons crashed to form one. In a study published last August, researchers speculated about another major milestone in the Moon's very early history, one that might account for its 2 very different faces. The near side of the Moon is low and flat, while the far side is high and mountainous. The paper posited that a tiny second moon once orbited Earth before slamming into its sibling, roughing up the larger satellite's surface. Scientists had previously believed that gravitational forces created the far side's highlands. The idea of 2 moons crashing to form one is not a widely accepted scientific theory regarding the origin of Earth's moon. The most accepted explanation for the moon's formation is the giant impact hypothesis, as previously described. This hypothesis suggests that a single, large impact between Earth and a Mars-sized object called Theia led to the creation of our moon. While there have been various theories and hypotheses proposed throughout the years to explain the moon's origin, they typically involve one significant impact event rather than multiple moons colliding. These theories are based on scientific evidence, computer simulations, and observations of lunar rocks and materials, providing a coherent and widely accepted understanding of the moon's formation. If you have a specific scenario or concept in mind related to 2 moons colliding, please provide more details, and I can try to explain or discuss it further. However, it's important to note that the current scientific consensus supports the giant impact hypothesis as the most plausible explanation for the moon's formation. Thanks for watching. Request you to subscribe the channel.